Lights, please. Now, this is a model of the Earth with its atmospheric shell. This is the vast magnetic field of the Earth. These wires represent the lines of magnetic force. Now, the Earth's field, like any other magnetic field, can bend the path of charged particles that move through it, but not of neutral particles. For instance, a neutral particle coming from outer space, this is the solid particle, this trailing tube's its track. Now, this neutral particle, having no charge, will shoot through to the Earth's atmosphere in a straight line, as if there were no magnetic field at all. So, if the space fagins were neutral solid particles, they'd be unaffected by the magnetic field, and they'd crash into our atmospheric ocean equally all around the globe. And since each fagin would create the same average number of henchmen, the resulting henchmen would rain down evenly over the whole Earth below.
Ah, yes. You see, if Fagin were neutral, the henchmen would rain down evenly over the whole Earth.
Charles, please. I have ears. I can hear.
I beg your pardon.
Now, let's see what happens if Fagin is charged.
Ah, yes. Let's see what happens if Fagin is charged, yes.
If the incoming particles were charged, now let's let these little red balls and red tubes represent the charged particles and their paths. If the particles coming in from outer space are charged particles, their paths would be bent by the field, as you can see by these few examples here. And the degree of bending is greatest where the particles come in at right angles to the lines of force, as they do here about the equator. As a result, and this is a key point, many of the particles coming in near the equator would have their paths bent so much that they'd miss the shell of the atmosphere completely. Look at this one, for instance, coming in at this angle, being so strongly, radically bent that it's gone out and hasn't come at all near our Earth's atmosphere. So too this one, coming in this direction and steaming out here again without ever getting near the atmosphere. While at the poles, charged particles would be bent very little, if at all, because they come in parallel to the lines of force. Look at these, how straight the paths are, compared to the curved paths of those near the equator. So, if the Fagins were charged, more of them would smash into our atmosphere at the poles than at the equator, kicking more henchmen into action beneath them at the poles than at the equator. And this so-called latitude effect could be measured by counting the number of collision pieces that rain down on us at various latitudes at the bottom of our air ocean. Lights, please.
Ah, the more henchmen below, the more Fagins above. Excellent reasoning.
The reasoning was simple compared to the legwork. For Operation Count the Henchmen, the cap and gown private eyes didn't just cover one street, one city, one county. They blanketed the whole globe, from pole to pole, from the halls of Montezuma to the shores of Tripoli. Sifted and evaluated, the data from this global legwork, not counting the professorial bunions, plainly showed that for every 100 henchman particles hitting the Earth at the poles, only 87 struck at the equator. Now that meant there were more Fagins at the poles than at the equator. There was a latitude effect.
And that could only mean that at least some of the space invaders were charged.
The detectives were closing in. The master crook was armed with an electric charge.
That means Fagin couldn't be a neutron.
Right, Mr. Poe. A neutron has no charge.
Then he must be a proton or an electron.
100 rubles, says Fagin, is a proton.
Covered with 2 pounds, my friend. I say he's an electron.
3 pounds. Takes 3 pounds.
2, Fyodor, 2.
We'll soon know. Now, Dr. Research, was Fagin's charge positive or negative?
Yes.
And wait till you hear how the learned Hawkshaw solved that problem. And with the Earth again. Go ahead, Doc.
Let's turn over our globe and its magnetic field so that we're looking down on the South Pole. Now we already know that an incoming particle with a positive charge would be bent to the right by the magnetic field, or to the left if it had a negative charge. Well then, an Italian physicist, Bruno Rossi, reasoned that if the cosmic rays were positive, the Earth's magnetic field would cause a majority of them to strike from the west, smashing more henchmen into us from the west. While if they were negative, a majority would strike us from the east.
And bingo, the missing clue came in from Mexico.
Yes, where 3 investigators, Arthur Compton, T.H. Johnson, and Lewis Alvarez, reported conclusively more henchmen came in from the west. That could only mean at least some of the cosmic invaders carried a positive charge.
Fagin's charge was positive. Mystery's clearing up, huh?
Clearing up. It's like daylight is mystery for children.
Of course, your story's over.
Of your 3 fundamental building blocks, electron, proton, neutron, only one was positively...
Please, let me crush these, excuse the expression, storytellers. Now, you got neutron, no charge. Electron, negative. Proton, positive. So, Fagin is proton. Give me the money.
Not so fast there, Fyodor.
Why not?
No, wait a minute.
He's
Wait,
proton.
wait a minute. Show him the positron still, Doc.
Positron stills.
Now, this is a photograph of a cosmic ray track taken in a cloud chamber on the 2nd of August, 1932, by Professor Carl Anderson at Caltech. Now, the light curve track seems to match the footprint of an electron, but instead of curving to the left in the cloud chamber's magnetic field, as a respectable electron should, this strange particle curved to the right.
Is Humpty Dumpty photograph, maybe, upside down.
That's one of the most famous photographs in science, Dosty. Got Anderson a Nobel Prize.
The first picture of the tracks of a hitherto unknown particle of matter, a positive electron.
A particle. Positively charged. Why couldn't that be Fagin, Dosty, instead of your proton?
I move we reject the entry.
Second emotion.
Third.
Why, Mr. Poe?
By introducing a new suspect at this late date, you have violated a cardinal rule of the detective story.
Yeah, it's cheating. It's my money.
But think of the impact of this discovery, Edgar. Why, it's as if your detective Dupin, searching for a human criminal, ran across an unknown species of man. It's astounding.
It's cheating.
A brand new kind of matter has been discovered.
Yes.
And a 4th henchman for Fagin. The positron.
Bah! What difference? Positron, proton, pimpleton. This is useful. These big doings about little nothings.
Now, wait a minute, Dosty. Out of little nothings like this have come the big doings of science. Newton wondering why an apple hits his head. Out of that came the law of gravitation. Röntgen, in trying to figure out why his photographic plates got fogged, came up with X-rays. Maxwell, tinkering with some tricky equations, came up with the key to television.
And this chase after little particles is the key for something big?
Just about the biggest something man ever ran into, Mr. Dostoevsky. Nuclear force.
Nuclear force?
That's big.
Nuclear force. We've heard rumors about that.
Exactly what is meant by force?
That's a large order, Mr. Poe. If I could answer that, I'd be 10 Einsteins rolled in one. But in general, by force, science means a strange, almost mystic quality or power possessed by matter. It manifests itself in 3 ways: gravitational force, electromagnetic force, and nuclear force.
Oh, yes, you see the 3, yes.
Now, in a sense, a force can be likened to an army. Force exerts its power through individual units, just as an army does through its individual units or soldiers. With gravity, the force that holds the whirling planets in their orbits, The smallest individual unit, the soldier that does this planet holding, is said by some scientists to be the graviton, although this graviton has never been pinned down or observed in any way. Now, if we focus down to just one atom, not large bodies, but just one atom. Helium, for instance, another force takes over. Electromagnetic force. Now, this second force keeps the atomic solar system from flying apart.
And the electromagnetic soldier?
That's called the photon. And unlike the graviton, this photon has been measured and directly observed. Now, if we go deep into the heart of the atom, into its nucleus, we come to the third and most sensational force. Nuclear force. That's the force that holds the protons and neutrons locked in the tiny nucleus. The awesome force man is now unlocking for his own use. The force which will surely change the way of life for every man, woman, and child on Earth.
And the soldier?
The soldier that does the holding in nuclear force? That, dramatically enough, came out of the cosmic ray chase, out of tracking down Fagin's henchmen.
Here's the way it happened. And boy, this really rocked the science world. In Japan in 1935, at Osaka University, a genius named Hideki Yukawa sat alone with a pencil and a piece of paper, and he came up with a most amazing prediction. He said that the soldier, the unit of this terrific new force, would appear, believe it or not, as a small particle, a piece of actual matter. He calculated it'd be about 200 times heavier than the electron, and get this, would live about 1/millionth of a second, then poof, it would disappear, die. Well, this was just too deep even for the highbrows. Yukawa's prediction dropped like a feather in the scientific pond. But meanwhile, the cosmic ray chase was still going on. Since the discovery of the positron, the scientific working stiffs were photographing cloud chamber tracks around the clock to see if there were more new particles among Fagin's henchmen. Well, up popped the devil. Seth Neddermeyer and Carl Anderson of Caltech and J.C. Street and E.C. Stevenson of Harvard all came up with a new track at about the same time.
What is it?
A real oddball. The track of a particle more than 200 times heavier than an electron, and which, if you please, lives only 1/millionth of a second or so.
Yukawa's prediction. His nuclear soldier.
Why, of course.
No, doggone it.
Oh?
This strange new particle, called a pi-meson, just didn't behave as Yukawa said it should. It wasn't quite the nuclear soldier he'd predicted.
There was a bit of disappointment on Yukawa's prophetic face. But there was no disappointment in the particle department. The bug-eyed cosmic ray detectives realized that they'd stumbled onto another brand new piece of matter that no one ever dreamed existed. And another henchman for Fagin's rogues gallery, the pi-meson.
And then some 10 years later came the happy ending, happy for the Japanese wizard. It came from the developing tanks of a laboratory in the University of Bristol, England. On photographic plates exposed on the tops of the Bolivian Andes and the French Pyrenees, 3 astonished cosmic ray hunters, an Englishman, C.F. Powell, an Italian, G.P.S. Occhialini, and a Brazilian, C.M. Lattes, ran across the track of a quite similar but heavier meson.
Eureka! This was it. This soldier did obey orders.
This newer particle, it's called a pi-meson, did seem to fit Yukawa's equations. His amazing prediction came true, and he was awarded a Nobel Prize for it. Now, Mr. Poe, I think I can answer your question. Most people believe that the unit of nuclear force, the tremendously powerful soldier that holds the heart of the atom together, is the pi-meson.
Pi-meson,
Yes.
And a 6th Fagin henchman got his name on the police blotter. The pi-meson.
But weren't the detectives a bit confused by all these odd henchmen of Fagin's?
Yes, I should think they would be, yes.
Confused. They were bewitched, bothered, and bewildered.
Yes, and they still are. Think of it. As late as 1932, science had the universe all neatly wrapped up in 3 little basic packages: electron, proton, neutron. Just 25 years later, in 1957, the number of separate and distinct particles of matter had jumped to at least 20.
Including 2 really out-of-this-world babies. The neutrino, a kind of ghost particle that leaves no footprints, yet apparently zips through lead as if it were butter. And the newly discovered antiproton, which some people think is one of the building blocks of an unseen world, a sort of left-handed world of matter matching the right-handed world we live in.
Yes, not to mention K-mesons, tau-mesons, hyperons, V-particles.
A veritable deluge.
And no one knows how many more henchmen are going to show up or what they're going to mean. Scientists are crying for a Moses to lead them out of the wilderness of nuclear particles.
I says proton.
Yes, yes. What about the detective story? What about Fagin?
Oh, yes, yes.
Oh, they nailed Fagin all right. To do it, they went right up through the air ocean and took his picture.
His picture?
Well, perhaps impression is a better word.
Okay, Doc. Impression. With this new detection gadget, it's a cosmic ray emulsion plate. It's very much like an ordinary photographic plate, only it's more sensitive, and it's got a much thicker coating of silver bromide. Now, the aim of the science detectives was to get a flash of old Fagin on here before he smashed into our air atoms. Well, obviously, that meant going very high indeed, way up almost to the top of our atmosphere, where the population of air atoms is very scarce. With these lightweight plates and a new kind of balloon named the skyhook, they did the trick.
Skyhooks quite easily carry instruments up to 140,000 feet or more and can stay up there for several days.
During which time police switchboards buzz with flying saucer reports.
Ah, but it's with rockets that we really take instruments up into Fagin's home territory. Up to 150 miles, up to where the emulsion plate is face-to-face with Fagin himself. From dozens of rocket flights, from literally hundreds of balloon launchings all over the world, picture of the master criminal began to emerge after a king-size chase of over 50 years. Here's what Fagin looks like, or rather what his trail looks like, as he smashes through the silver bromide on the photographic plate.
And this is what happens when Fagin hits one of the silver atoms square on the nucleus. Weight for weight, he's got the biggest sock in the universe. The first to actually mug Fagin were some Chicago detectives.
Yes, a group of physicists headed by Marcel Schein. From microscopic examinations of the tracks left in their emulsions, they announced that most of the Fagins, the primary rays from outer space, were protons, naked hydrogen atoms stripped of their electrons.
Protons! I was right. Give me the money.
No, Fyodor,
Yes,
not so
Charles,
fast.
I win the
Order,
money.
gentlemen. You have one
Order, yes.
Order, gentlemen.
Yes,
No,
yes.
you have
I'll
one.
ask him. I'll ask him.
Order.
Doctor, search me. I was right. No?
Only partially right, Mr. Dostoevsky. In 1948, physicists from the universities of Minnesota and Rochester found other primary tracks, too heavy, too highly charged to be protons. And the most numerous of these were made by naked helium atoms. And in addition, the tracks of still heavier atoms were found. In other words, the Fagins are really atoms, common familiar atoms, stripped of their electrons and hurtling through space at unholy speeds. Atomic bullets from beyond the beyond, crashing into us with almost the speed of light.
And when he says crash, he means crash. These cosmic ray babies crack into us with energies of more than 1,000,000 billion electron volts. More than 5 million times as strong as an A-bomb atom. That's our space boy, Fagin. And his identity? Naked atom.
Amazing. Absolutely amazing.
My money.
But no more amazing than the detectives who tracked him down.
Do you mean to say they actually know where he comes from?
Well, they've got one pretty good idea. Tell them about it, Doc.
Well, many scientists now think the cosmic Fagins are being spawned continuously in our own galaxy, the Milky Way. They believe that all stars, including our own sun, are constantly casting off particles into space through surface explosions, and that these cast-off star particles, zillions and zillions of them, gradually acquire their cosmic speeds and energies by being bounced back and forth between galactic clouds.
Galactic clouds?
Yes, our own Milky Way, which looks something like our neighboring galaxy, Andromeda, contains not only billions of stars that spiral around, but also millions of truly enormous galactic clouds composed of dust and gas. These galactic clouds float and swirl through the Milky Way in all directions. Sometimes they look black and they obscure the stars behind them. These swirling clouds apparently create gigantic magnetic fields. The late Enrico Fermi, one of the great pioneers of modern science, Fermi suggested that within our Milky Way, gargantuan badminton games go on, in which the players are these huge magnetic fields, and the birds are tiny naked atoms which have been shot into space from erupting stars. And the atoms are naked because the star heat is so intense that atoms can't hang on to their satellite electrons as they do at normal temperatures. When such an atom is exploded into space from a star, it will eventually collide with a magnetic field and bounce off. It will bounce off with more speed if the field is moving toward it. Years later, it runs into another gigantic field and is sent shooting off in another direction. After 1,000,000 years or so of this being batted back and forth, these atoms, they're our fagins, and remember their number is countless, are kicked up to almost the speed of light and sent hurtling through our Milky Way in all directions. And the tiny dot, which is our Earth, moving through space, sails through this myriad of shooting particles, and a tiny fraction of them crash into us as cosmic rays.
Gentlemen, do you realize what this means? The Fagins bombarding us from outer space are pieces of matter from billions of stars. And since these space bullets are the same atomic particles we have on Earth, that means the stars are made of the same stuff we're made of. A part of the eggs you had for breakfast this morning could have come from Orion, or from the Big Dipper. And some of the carbon in this young lady's shining red hair might once upon a time have been stardust from an exploded supernova, or from the Southern Cross. Why, you could almost say that in tracking down Fagin, the science detectives uncovered material proof of the oneness of the whole great cosmos.
Mr. Scientist, for highbrows, this could be exciting. Maybe. But what is meaning for common people who work, love, hate?
Yes, yes. What is the meaning for ordinary mortals?
Oh, a very big meaning indeed, Mr. Dostoevsky. It's possible that how people work, love, hate has been and is even now being affected by cosmic rays. It's possible that in the millions and billions of years they've been bombarding the Earth, these cosmic space bullets could be partly responsible for evolution by causing mutations, sudden changes, as they smash into our reproductive genes.
My word.
Why, Dosti, it's conceivable that your enormous writing talent could be traced to some well-directed cosmic ray hitting your great-grandfather in just the right gene.
My writing? Cosmic rays?
Do you realize what this would mean philosophically, Edgar? That changes in living things may be controlled by the stars.
And still more significant, Mr. Dickens,
Yes?
someday, out of the strange case of the cosmic rays, out of this out-of-the-world detective story, may come the answer to the great riddle of what makes the universe tick.
Well, gentlemen, how about it? Do we get the Edgar?
Charles.
Yes, yes.
I make my vote now.
Yeah, I know. Yet.
No, not yet. Science is for people. I thought it was just for long hairs. I vote yes.
You do?
Yes. A truly remarkable story.
Hey, Doc, did you hear that?
But an epic adventure of the human spirit, the mind of man, daring to explore the unknown reaches of the heavens just to track down these tiny particles of stardust, so packed with primeval power, they come winging with the speed of light. Celestial messengers from out where the morning stars sing together.
Good line, Charles. Excellent poetry.
You like it, Fyodor?
But what is the message they bring, and why?
Huh?
What?
Gentlemen, we thank you for a saga of brilliant scientific accomplishment. But as a detective story, and that's what we're judging, as a detective story, your tale has a fundamental weakness. Motive.
Motive.
Fyodor, they've established no motive for their cosmic fagins.
But Edgar.
Why do they bombard the Earth?
Edgar, if they knew motive for cosmic rays, they'd have answer to great mystery of creation itself. I vote yes.
I vote no. Their story's unfinished.
Charles, you vote yes. No?
You know, I'm reminded of Isaac Newton.
He's reminded. It's a good story. Give him
Just
the
a moment,
answer.
Fyodor. Just a moment, Fyodor. I haven't finished. I'm reminded of Isaac Newton, perhaps the greatest scientific mind that ever lived, and how he humbly described his monumental discoveries as now and then finding a smoother pebble or a prettier shell, while the great ocean of truth lay before me. Well, that great ocean of truth still lies undiscovered before you.
Briefly, Charles, how do you vote?
I vote we invite these gentlemen to come back in 50 years to tell us what new chapters they've added to their cosmic tale.
Ah, excellent, Charles.
Thank you.
Most excellent.
And who will write these new chapters? The young. The inheritors of all the knowledge and culture of the ages. Of all the dreams and hopes of those who went before us. What an exciting time to be young.
Yes, and what a glorious opportunity to add to man's history, to harness these nuclear fires for man's use, to accept the challenge of creation, and to use the gifts God gave us to explore the grandest of all frontiers, the universe. For the more we know of creation, the closer we get to the Creator.
Gentlemen, here's to Stardust.
The Bell Telephone System takes pride in bringing you this program in its series of shows on science. We wish to express our gratitude to the distinguished Board of Advisors who guide the choice and treatment of scientific matter for the series. Biology and genetics, medicine, bacteriology and botany, chemistry, geophysics, physics, anthropology, mathematics, engineering. For the program you have just seen, our thanks to the special advisors who have suggested and checked the scientific material. The Bell Telephone System is indebted to all these men and to many institutions for the generous support they have given this venture in public education through entertainment.